welcome to today's webinar on the PKN Waste Heat Recovery Contest. My name is Jonathan Yakasha, and I will be your host and moderator for this webinar. Please note that this webinar is being recorded and will be transcribed for viewing on the PKN ORLEN page on NineSites at a later date. To start off, I'll go briefly through the agenda for today's webinar. First, I'll provide the speaker introductions, and then our speakers will provide an overview of both PKN ORLEN and the contest. Next, we'll present the frequently asked questions for this contest, and then work through a live question and answer session. To participate in the live Q&A, please submit your questions at any time through the live Q&A chat box. We will collect and present these questions during the live session. If, however, we don't answer your question during today's webinar, please note that we will be transcribing and answering all questions asked during this session and posting them on the PKN ORLEN page for viewing at a later date. And finally, we'll wrap up with information on what you can do today for the PKN ORLEN contest, including where to register, how to stay connected, and how to submit your proposal. Now, I'm pleased to welcome the following speakers to our webinar this morning. From PKN ORLEN, we have Andrzej, Head of Strategy, Jacek, Director, Technical Lead, and Radek, Technical Expert. And from NineSigma, we have Joost Sennens, PhD, Program Manager, NineSigma. First, we have the overview of the Waste Heat Recovery Contest. NineSigma, representing PKN ORLEN, seeks submissions for waste heat recovery technologies that can operate with low-grade heat of about 115 to 120 degrees Celsius. The successful solution will address specifically the heat lost from the top of the K1 distillation column located in PKN ORLEN's Plock refinery in Poland. And now we'll hear from Andrzej, who will provide some background on PKN ORLEN. Andrzej?
Thank you. Hello, everyone. It's a great pleasure to have this conference, this webinar with all of you. We are pretty excited starting this initiative. So I think we should just provide you with a brief introduction of our company, who we are, where we come from. ORLEN is the largest company in the CEE. We are involved in the refining of crude oil, as well as in the petrochemical sector, fertilizer sector, and we also operate the largest retail network combined of the fuel stations in the countries. In 4 countries. We operate refineries in the 3 countries, in Poland, Lithuania, in the Czech Republic, and we also are advancing our growth in the upstream business by recent acquisitions of production assets in Canada. We are also one of the leaders of the process of exploration of shale gas in Poland. What is important to be noted also that we are the only Polish company present in the global Fortune 500 index and the only company named the world's most ethical company in Poland. Next slide, please. And now, why we are doing this? I mean, why we decided to start the crowdsourcing initiative? Well, first of all, innovation is one of our strategic priorities. So we started by developing our internal capabilities, and we have a team. We are looking into several innovative projects that we could explore in order to prepare ORLEN for the unknown future. But we also figured that it would be really a good idea not only to develop these innovations inside by the means of internal resources, but to turn into the global market of experts and enthusiasts and try to tackle some of the key issues that we have with the help from outside. So we think of a number of different projects, but this is the one we started with. That's why we are approaching the waste heat recovery issue together with you. We hope to gain some great ideas and some great concepts by running these initiatives, and we are really happy that we were able to engage so many interested parties and individuals so far. Thanks a lot, and next slide, please.
Great. Thank you for that introduction to PKN ORLEN. At this time, Jacek and Radek will share with us some information on the details of this contest. Gentlemen?
Radek Gospoś. Good morning, everybody. So let me start with a very short introduction to this challenge. Crude distillation columns are probably the biggest or the major energy consumers in all refineries. The main reason for that is the distillation process is not very efficient. We put a lot of energy to the bottom of the column, but by providing stripping steam, by providing hot feedstock, but at the same time, we condense vapors at the top of the column. So please take a look at this figure. This is a typical section of the condensation section of the atmospheric column. The stream number 1, which is the vapors, this is the light hydrocarbons in the gas phase, are sent directly to the equulets, where they are partially condensed and subsequently they are directed to the reflux drum. As a result of condensation, a lot of heat is irreversibly released to the atmosphere, so a lot of energy is just wasted. Even though it is a low temperature heat, like approximately 120 centigrades we have at the top of the column, but in terms of pure gigajoules, it is a really significant portion of energy. According to our simulation, it is over 100 gigajoules per hour, which is wasted just right now. So the purpose of this challenge is to find a way, to propose a solution where some part of this heat can be recovered and efficiently utilized to the process. On the picture you can find the main streams, like for example the stream number 3, which is the off-gas from the separator, from the reflux drum, the stream number 5, which is the sour water, the stream number 7, which is the naphtha stream, which is directed for further processing, and the stream number 9, which is the reflux drum. For all these streams, you can find in the summary of the solution the main properties like temperatures, pressures, flow rates, densities, enthalpies. So they are also tabulated in the summary of the solution. So next slide, please.
Okay, Jacek, this side. I think that the most interesting for you, apart of that what Radek said, is available utilities we have at the plant, which help you to, I believe, find the solutions for us. So let's start from the fuels. We have a fuel oil and fuel gas, but please focus on the fuel gas as we are under the activity of elemented fuel oil as too expensive fuel for our refineries. So focus on fuel gas. I think that it would be good to know at least what kind of temperature we have on particular utilities, and regarding the fuel gas, we can observe the temperature from 15 to 45 degrees Celsius. The next one is steam. Steam, practically, for you, the most interested would be probably 0.6 megapascal steam, which is our heating steam. And this temperature varies from 165 to 175 degrees Celsius. And condensate, in condensate collector, the temperature of the condensate we send to our power station is from 94 to 100 degrees Celsius. Regarding the cooling water, the temperature of that is depends to the seasons, and it varies from, let's say, 16 to 24 degrees Celsius. The next one is raw water, which is similar to cooling water temperature. Air and nitrogen is has an ambient temperature, so it's mainly rely on season. And as you can see, electric voltage which we have available in our plant is 6 kV, 0.5 kV, and 230 volts. Okay, next slide, please.
Radek, for the purpose of evaluation, we identified some of the criteria which should be satisfied for this project. And first of all, we should know if the project is cost effective, if it is economically justified. So that's why we would like to know what is the operational expenditure, capital expenditure, efficiency, and calculated internal rate of return. The solution also should specify what is the type of used utilities to make it work, and what would be the type of energy which will be recovered, like for example steam, electricity, maybe cooling capacity, and others. Also specify that there are some crucial parameters like temperatures and pressures and the top of the column that should be unchanged, so it also has to be reflected in the solution. Also, what is very important is that the solution has to be completely reversible. So what does it mean? It means that in case of some disturbance, some disruption of the plant, like for example a leakage on equipment, like just a malfunction of the equipment, you have to have ability to quickly reverse to the previous configuration. So a very good example of that is like bypassing of the equipment. Anti-corrosion protection is also very important because the solution would affect the most critical section in terms of corrosion rate on the whole plant even. So, the solution providers should refer to the subject, what is the impact on this corrosion rate, and if it is, for example, detrimental impact, they should also maybe provide some mitigative actions like proposition as to the appropriate metallurgy or something like that. The solution must be also flexible, which means that it should be operational for minimum and maximum capacity of the plant, or even 110% of the capacity of the plant, which was specified in the summary of the challenge. A very important aspect is that the solution providers, the respondents should refer to what is the impact on the environment. If this solution is completely environmentally friendly, or maybe this solution can contribute to some other complaints. So it's also a very important issue. The solutions should be compliant with the ATEX directive, which determines the conditions which are necessary to be implemented in the explosive atmosphere, so like typical for refineries. And also it has to be measurable in terms of different parameters, maybe energy, and integrated with the DCS system. Next slide, please.
Great, thanks for that overview, gentlemen. At this time, Jo Senens, NineSigma Program Manager for this project, will tell us about the contest criteria and provide a project timeline. Jos?
Okay, so the contest criteria have been specified in the text, so I hope you all have read the document that we put on our website. But to summarize that, if you participate and send in a proposal, you should try to be as compelling as possible in terms of the performance of the solution that you have, and of course the economics, and take into account the physical and operational constraints that we have described in the contest document. For possible solutions, the field is open. Orlen is open to approaches that use available heat, for example, to produce extra electricity, or to provide power to drive compressors, or even to use the heat to convert the heat into chemical products, so to help into conversion of useful chemicals. Next slide, please. So important is the timeline. So we launched about a month ago, 1st of October. So the contest is now 4 weeks live. Important, of course, is the 9th of December. Then the submission will close. So at 5 p.m. Eastern Time in Cleveland, the website will close for all participants. So I advise all of you not to wait until the 9th of December. Try to do it a bit before in case of problems with internet connections and so. In case you have problems submitting a proposal, we can always help you with that. But a strong advice again, don't wait until the last minute because then you might get into trouble. Next slide.
Great, thank you, Jos. So, why should solution providers be interested in this challenge? Jos?
Okay. So the total opportunity that we defined, there are several levels. So the first is a contest itself. So Orlen is prepared to pay 30,000 euro for the 3 best proposals that they receive. But on top of that, they are looking for a solution that can be implemented in the PKN ORLEN plant in Plock. So there will be a possibility to negotiate a supplier contract to install a good solution. At first at the refinery in Plock, but there are other refineries that PKN ORLEN has in operation. So in total it could go up to 7 installations. There is another way to get your attention. They're also prepared to negotiate at their discretion R&D grants to further develop promising technology that is not yet ready for practical implementation. And it could also happen that they will help you to market and demonstrate successful pilots together with PKN ORLEN. Next slide.
Great, thank you, Jos. Before we proceed with the contest frequently asked questions, I would just like to reiterate that if you have any questions for the PKN ORLEN team or for Jos from the NineSigma team, please use the Q&A chat box to submit your questions. If we don't get a chance to answer your questions live during today's webinar, we will transcribe and get those questions answered for you. First, NineSigma related questions for Jos. Jos, what about intellectual property or IP? How am I protected?
So we are protected because you cannot submit anything that is confidential. So, and we do not take any IP from you. So you keep the IP in your own hands. In case Orlen is interested, you will have to negotiate. You can negotiate the IP rights together with PKN ORLEN. So by participating, you do not give away any of your rights. So even by accepting a prize award, then you agree to execute. You should be prepared then at least to go into a confidentiality or non-disclosure agreement between you and Orlen. So all the details are also in the contest terms and conditions that are on our website. So it's a document of about 10 pages. So if you are interested and you are anxious, I should advise you to read them. And if you have questions or doubts, forward an email to the contest and we will try to answer these as soon as possible.
Great, thank you, Jos. What's the best way to respond to this contest?
So the best way to respond is to register first on the website. So also an advice, don't wait until you have your proposal ready. Already register now because it will probably make you gain some time and you will see how it works. Then you can download the proposal template, you fill it in and you can upload that. You can also download and sign the consent and release form. So also important is that if you put information on the forum itself, that will not be part of the proposal. So everything that you submit should be uploaded or entered into the contest proposal template. And again, if you have questions, we will help you with that.
Great, thank you, Jos. And just to add on to that, if you have any questions, you can submit your questions to phd@ninesigma.com. That's the email address for the provider help desk. We have people staffing that email address, and they will get your questions answered as quickly as possible. Now, these following questions are directed to the PKN ORLEN team. What is the deadline in order to submit a proposal? Sorry, my mistake. That one is for Jos.
Yeah, it's already set. It's 5 p.m. Eastern time, so the time that is available, that's applicable in Cleveland, Ohio, in the United States. So that would be in Europe. It would be 11 o'clock Central European time, and of course a different time if you are from Australia or Japan or China.
Great, thank you, Jos. The contest summary includes a range of possible approaches. Are some of these already tested by PKN ORLEN?
Yeah, take the side. Honestly speaking, except pinch analysis, we didn't. Okay, except pinch analysis, we didn't test any of them. Some of them we consider to test, to focus on, but in the meantime we launched our contest, so we give a chance our solvers to find this solution. Talking about the pinch analysis, we consider that putting the energy to the preheated train is, from economical point of view, not acceptable, not applicable for us because of the too long payback time.
Okay, great. And this next question is kind of the reverse of that. Are there any known technologies that are not of interest to PKN ORLEN?
Radek, actually, we excluded only 2 different solutions from our interest. This is not the subject of our interest. And one of that, as Jacek mentioned before, it is the heat exchanger, which would be installed on the overhead line of the atmospheric column and to preheat the crude oil. Actually, it turned out that even though, according to our simulation, it turned out to be a feasible option, but it would require a very extensive modification to the heat exchanger network, so resulting in the very high capital expenditure. But also, this part of energy which would be acquired on the beginning of the heat exchanger network would be really much mitigated coming through every one heat exchanger to the furnace. So a lot of heat will be actually reduced. Another type, which we also specified in the summary of the contest, is that currently we use flue gas from the furnace to provide heat to the air. So we also would like to exclude preheating the air to the furnace by this case. Thank you.
Great, thank you. At this time, we'll begin the Q&A session. If you have any questions, please use the chat box. Send your questions in. If we are not able to answer your questions during today's webinar, we will transcribe the questions and post the questions and the answers on the PKN ORLEN page on NineSigma. I would strongly encourage you, if you have questions about this contest, to avail yourself of this opportunity to speak directly to the PKN ORLEN team and the NineSigma team to get your questions answered. I believe we already have our first question in. Jos?
Yes, we have a list of mainly technical questions and a few questions on the business side. So I propose that we start with the technical questions. And the first question is probably easy to respond. So it's about the constancy of the available temperatures. It's 120 degrees. Is that?
No, it actually can be too flexible. It is like generally from 115 to 125. So the 120 is the average, but for the calculation purposes, please consider this specified constant temperature, which is approximately 160. Yes.
So the temperature that we put in the table is the one to use for calculation.
Yes, exactly. But generally, in the refinery, of course, it depends on a lot of factors, the ambient temperatures and the mode of operation. But this temperature is tangible, so it is like within a range of 115 to 125.
Can you comment on the ambient temperatures? Is it in the winter -20?
Yes, average temperature in Poland is like +20, let's say, but in the winter time it is approximately -20, even to -20, and during the summertime it is +30 centigrade. So.
Next question is also dealing with heat exchangers. So is a question on, is it possible to box in a section of the high level, so the heat exchangers that are located at a certain height, to exchange heat with a hot water circuit, and to bring that hot water or maybe steam to a ground level based power station?
Jacek, yes, it's possible. Each of the solution is very welcome, but we need to have in mind 2 issues. First is the weight of the new solution, because I understand that it would be put on the existing rack structure, and this rack structure have to be recalculated for that. And the second issue is let's remember that the solution must be reversible. Yes? So the air access to the air coolers must be fully accessible.
Yeah, that was also a question. Why is it so important that it's reversible, and what do you really mean by it being reversible?
It's important because, of course, we need to take under consideration that the period between turnarounds is somewhere like 4 or 5 years. So the solution has to work 24/7 all the time. And in case of failure of the new solution, we need, and to put it to maintenance, for example, we need to reverse our old solution and run this column constantly.
So any solution that would, let's say, remove part of the heat exchangers is not possible.
We would like not to resign from this actual solution.
Is it possible to propose a solution which is operable in parallel to the existing ones and enabling a different throughput through different degree of energy recovery?
Yes, it is. Of course, we just even talked with Radek that of course some solutions which are not which cannot be put in changing of the capacity, let's say, it gives a stable energy recovery, but for that we need parallelly our actual solution even. So of course most accurate regulation in solution is better because much precise recovery will be achieved.
Yeah. So another last question on temperature. Why is it so important to maintain the 61 degree as a final temperature of the stream?
Radek. Okay, so as we specified in the summary of the proposal, that some parameters should be maintained unchanged, and this is the pressure and the temperature at the top of the column. So, for example, if we for example change the temperature, for example, so it will affect the temperatures of other streams, like the reflux, which is responsible for the distillation rate, for the specification of naphtha. But of course, in here, for example, we could have some flexibility, at least. But it will also affect the stream number. Let me look at the stream number 7, which is the naphtha stream. It goes for further processing. So if you, for example, recover more heat from the stream number 2, reducing from the vapors, reducing the temperature below the 60, we have to add some more energy to the stream number 7. So, for example, the effect of recovery will be reversed to some extent.
Okay.
That's not the point.
But the most important is, of course, our tower and energy balance inside it.
Okay. Another question that just comes in. Energy recovery technologies are usually site dependent. How could we get some more info about the application? Are you looking for a specific technology? Where can I find specifics of the waste flue gas, for example?
Radek. So let me specify that we are not looking for the specific solution. As we specified that we are interested in different scenarios. It can be, as Jacek said, it can be in parallel, for example, solutions, independent ones, completely new methodologies, existing technologies, or even hybrids of new technologies. So we are actually not looking for the specific solution. And the question, there is also the question, where do I find the specific of the waste flue gas? So we also emphasize that the flue gas is not taken into consideration. This is not only the vapor stream from the atmospheric column.
Okay, thank you. Then there's another question coming in, I see. Can we get or provide schematics of the project to understand the source of this waste heat?
But I think this scheme is already provided. The source of the waste heat is the excess of heat which is needed to heat up atmospheric tower. Of course, to distillate the particular fractions, we need to heat up crude and cool down some streams to condensate them and take them out from the tower, and finally the lightest stream is getting out on the by the top of and the overhead. Yeah. So the source is speaking shortly. Source is a tower. Yeah.
Okay, thank you. In terms of the recovered energy, is there a degree of preference? So what would be the highest value for Orlen if you make electricity or if you get cooling or heating capacity?
Okay, it's difficult to simply say that which type is in preference. From the price point of view, which we have as an average in Poland, we would like mostly save, let's say, electrical energy, then natural gas, then steam, and others. But we need to take under consideration efficiency of the solution. For example, having electric energy efficiency on the level of 10–15%, even with high price, it doesn't mean that the solution will be the best. Yeah. So we haven't got the preference which one will be the best, knowing the average prices of particular energies. I mean the stream. I mean natural gas, electricity. We can calculate easy steam price, knowing natural gas price. So the solution should be as much efficient and profitable as possible, but there is no preference of the.
Yes, thank you.
Of the form of energy.
Speaking about the specific utilities, are you prepared to provide participants with the price of these utilities? Because there's information that is vital for evaluating the cost effectiveness of the proposed solution.
We just talked it over during our journey to Warsaw today, and yes, you can find the average prices which are available in internet, and you can refer to them, but to give everybody, let's say, the same numbers of prices, we can, together with Radek, prepare on the website these prices for calculation to give a chance everybody talking about the same numbers.
Okay, thank you. Jonathan, you want to give a message?
Great. Sure, yeah, thank you, Jos. First off, I just wanted to say that if you have any questions, please use the Q&A chat box to submit your questions. This is an excellent opportunity to ask your questions directly to the NineSigma and PKN ORLEN teams and get them promptly answered. I also know that some of you have been reporting some audio issues. I would just like to reiterate that this webinar is being recorded and will be transcribed so that if you're having audio issues at the moment, you'll be able to access this resource soon. Jos?
Okay, your request for questions helped. There is another one coming in. It's similar. Is heat exchanger preferred, or can the solution be interfaced directly with vessel or pipe product? So that's more on the location of or how to insert the proposal, this technology.
It's not excluded, of course. We are, as you mentioned, that we are looking for different ideas. So, if it is the concept of the specific respondents, yes, we don't exclude that it is possible.
So, it can be directly put in the pipe.
Yes.
Yeah.
It requires the calculation and the thorough simulation, but It's not excluded.
Okay.
Sometimes it's very difficult to imagine even a solution which will be outside the pipes here.
There's a question coming in on the utilities. Are there other utilities available which could be utilized for the project? For example, from adjacent plants?
Yes. Radek, we specified some utilities which are available on the crude distillation unit. In some of the cases, of course, it can be possible that we can, for example, use different utilities from adjacent plants. Like, for example, an example, like, for example, hydrogen from the hydrogen production unit. But of course, in that case, it's really hard to predict because you have to evaluate in terms of availability of this utility and also supply and demand balance for the whole refinery, even at different modes of operation. So, but if a solution provider have some concept which would like to utilize the vapor stream in conjunction with this utility, which is not available on the crude distillation unit, but on other, for example, so he can, before proceeding with the project, he can submit a question on the website, so we'll refer to that as soon as possible.
Okay.
But please, Jacek, please remember that for that, if we haven't good utilities at site and the crude distillation unit providing of other utilities or streams due to the distance between plants will need prompt capex.
A question on efficiency. Is the 10% efficiency a limit for power generation only?
This 10% which we mentioned is our rough estimation, because the most important is payback time or IRR for this for proposed solution. Yes. Speaking in the simple words, solution provided by our solvers must be economically applicable. Yeah.
Yeah. There's a question on the requirement. If we do not satisfy all the requirements that you put in the contest summary, due to lack of expertise in the specific field, for example, the calculation of support of the structures, can I still participate, or do I really need to fill in all criteria?
Radek, absolutely. First of all, we are aware that some of the respondents can be leading companies or professionals which have a great expertise in implementation of similar projects on the refinery. But there can be, of course, university professors, students who don't have access to the process simulators, who, for example, don't have an expertise in every field, but they can still have a very good idea, a very innovative solution. So even if this is the situation, if you don't satisfy all requirements, all criteria, we kindly encourage you to submit your proposal.
Okay. What else do we have? There's a question more on the business side. Is PKN ORLEN interested in potential cooperation outside the contest? Who will answer that?
Can you repeat the question?
Is PKN ORLEN interested in potential cooperation outside this contest?
Of course, and I think that it was mentioned in our contest that the benefit for the solver is not only the price we set for the winners, but also the possibility to cooperate with us, and especially with universities or other schools. We are keen to extend the deliver of this this solution, and would love to cooperate with schools, universities to continue and to find even the future solutions. Yeah.
Question on the speed of implementation of the solution. How fast can you implement the solution on your existing installation?
Radek, of course it depends on a lot of factors. Actually, first of all, what we will see, for example, what is the quality of the proposal? If it is the general, for example, overview, simple simulation, or maybe a very meticulous simulation based on the rigorous studies. So in that different cases, for example, we can differently pursue the project. For example, if we have a reliable data based on the rigorous studies, so we can, for example, just immediately start with the basic design or even engineering project. Of course, it also depends on the what is the complexity of the specific project. For example, if it is simple for implementation, it will, for example, take a few days for implementation. We can shut down the plant for this specific date, for example. We have to, of course, to select the appropriate period for that. But for example, if the implementation, the duration of the implementation will be like 1 month, so we have to strictly fit into the schedule turnaround period. So it really depends on a lot of factors. But at the earliest, I think that it would be in 2017.
Yeah.
So in 2017,
yeah.
then you'll have a shutdown.
Yes, we have a planned shutdown of the crude distillation.
And that's then the 30 days that we mentioned in the article.
Exactly.
The text. Okay. There's a question on: do we need to be a research team, or can individuals also participate?
Yeah.
So individuals can also.
Yes, of course.
Yes, exactly.
Yeah. Okay. There is a question on past collaborations. Has PKN ORLEN already collaborated a lot with universities in the past, in Poland or even outside Poland?
Yes, in the last couple of years, PKN ORLEN often collaborated with different universities on the different subjects, like feasibility studies, in different topics like corrosion, for example, and others. So just the situation was always.
Yes, in Plock we have also university which is dedicated for our, some directions are dedicated for our company directly for history, and we have a close cooperation with them also.
Okay.
Jos, before you proceed to your next question, I would just like to reiterate that if you have any questions, please use the Q&A chat box to submit your questions, and then Jos or the PKN ORLEN team will do their best to answer your question during today's webinar. Thank you. Jos?
Yes, let me see what I still have on the list. Are you also offering job positions for R&D experts as a result of this contest? So we mentioned that you could do a research project, but are there job openings for researchers itself?
Yeah.
Yes, I think that it's not excluded that there can be some. No.
You mean that are we offer the position for R&D experts? Yeah.
Yeah, that's the question.
Okay. Job position is not a part of primary reward in this context, but if you became finalist, we will enter business negotiation with you, and position in PKN ORLEN might be part of the deal, of course. So it's not forbidden. If you are clever enough, you are very welcome.
Okay, thank you. Are there also internships available? So can a student do a stage?
Yes, of course. All participants are eligible to apply for internships.
And what is a typical timeline that you want for a stage? Do they need to stay a year or half a year at least?
Really, it's hard to define, for example, what is the best period just to apply for the
half a year.
Half a year minimum?
Yeah,
probably. Yes.
Yeah. Toxicity.
Okay.
There's a question on the definition of toxicity, so we have to think about it.
I wouldn't even talk about the toxicity because not the part of this contest. We are talking about the hazardous areas mostly and mainly because, of course, crude distillation, crude is not itself is not a toxic when you handle even directly with it. Some compounds are toxic, but you can find toxic condensation on the quite different areas of our refinery. But talking about the hazardous areas, of course, each area is flammable. Each of compounds is flammable, and we use a special ATEX technology, which is of course much more expensive than the standard one, but it's required due to safety standards.
Is that related to the criteria that you want to spend more money when a solution is proven in the petrochemical industry? What does it mean, proven in petrochemical industry?
That means, yeah.
Yes, actually, for example, if the solution was proved to be effective, for example, on refinery, on petrochemical area, for example, so we are not dealing with the quite completely new methodology. So, so then the capex is not very crucial. So we can, for example, risk more because this solution actually is already implemented somewhere. So it's not some kind of risk, for example.
So it's less risky for
less risky. Yes, exactly.
Please take in mind that the crude distillation unit is the heart of refinery. We cannot allow risk too much. Yeah.
Okay, thank you. There is a question on the level of innovation. Is there a minimum innovation level that you want, or do you also accept clever use of existing old technologies?
Radek, I will try to answer for this question with a question. For example, first of all, how you can measure the innovation. So of course it is at our own discretion, for example, that we evaluate also in terms of what it is. We can't evaluate, for example, if this is more innovation, for example, than the other solution.
But of course, we are open for the proven good solution, which maybe we don't know it yet, but they exist around the world.
Okay. There is a
Jos, let me just take this opportunity to let everybody know that we have about 10 minutes left in today's webinar. One final reminder, if you have any questions for either the NineSigma team or the PKN ORLEN team, that would be an excellent opportunity to ask your questions and get a prompt answer. Jos?
It's not very detailed information, so we can't refer to that.
There's a question on flammability, but we do not know how to answer that.
So because
we can maybe do that afterwards by email.
It's not actually that we don't know the answer, but for example, there are a little information, for example, describing the problem. So, for example, so if respondent, if the solution provider can't provide more information, so we'll refer to it on the website, which is dedicated to this challenge.
Okay. There's another question. When you mentioned that you did a pinch analysis on the whole plant. Did you include heat pump options in that analysis, or was it only based on heat exchangers?
We didn't, Jacek, we didn't include during the pinch analysis any other solutions than heat exchangers, but from my understanding, from energy balance point of view, the way which we pick up heat from overhead and transfer it to crude preheat train shouldn't have influence on result as we treat that source as a source of energy. Yeah? So it doesn't matter if the source of energy is delivered by exchanging or this is delivered by other way. You have a heat or utilize. And this is a question that the question why pinch, why we didn't use the pinch, because of the mitigation of the heat results or heat influence on the heat trains by followed exchangers, and the change will be too expensive for us. And so from economical point of view, it doesn't.
So if people want to propose heat exchangers, they should include a good calculation on the feasibility.
Yeah.
Okay. Thank you. There is a question on incentive mechanisms. In Poland, do you have any incentive mechanisms for any energy recovery? Because it might highly affect the economic feasibility of a solution.
If I understand correctly, this question, yes, there are some organizations in Poland, for example, that there can be some of the very innovative solutions can be refunded, which will reduce the capital expenditure.
So refunded by the Polish state or European Union?
Environment department.
So that would be part of the financial balance of the proposal.
But you know, we can apply for that. That doesn't mean that if you have an innovation solution, you for sure we will. Yes.
So if people think they can use incentive mechanisms, they should indicate what they expect to achieve with that, and then we can PKN ORLEN can maybe have a look and help to find incentives from the EU or Polish government.
Definitely.
All right, great. Thank you, Jos. At this time, we'll begin to wrap up today's webinar. If you have any questions that you would like to submit to the PKN ORLEN team or to Jos from the NineSigma team, you can use the email address that's on your screen, phd@ninesigma.com, and we'll make sure to get it to the appropriate individual to get an answer for you. Now, what can you do today? You can visit the contest website, ninesites.ninesigma.com/web/PKN ORLEN Waste Heat Contest. You can register to receive updates, view the frequently asked questions, and join the community. You can also visit the forum and subscribe to the forums to be kept informed of any updates. Again, if you have any problems or questions with submitting your proposal, you can reach the Solution Provider Help Desk via phd@ninesigma.com or using the phone number on your screen. Please bear in mind the very, very important submission deadline of December 9th, 2015 at 5 p.m. Eastern Time. After 5 p.m. Eastern Time, you will not be able to respond to the contest. So please be sure to get your proposal in well in advance of that time. That 5 p.m. Eastern U.S. time is 11 p.m. Central European Time. Once again, this webinar is being recorded and will be posted online along with a transcript at a later date for viewing and refreshing of your information. Thank you very much for your time and attendance today. Thank you very much to our panelists from the PKN ORLEN team and Jos from the NineSigma team. Thank you and have a good day.
Okay.